All right, so we've been talking about different types of velocities. We've done constant velocity, we've done average velocity. Now we need to talk about instantaneous velocity. You're going to get a chance to practice right away here. So there's two possibilities when v inst is to be calculated. So instantaneous velocity, how fast are you going right at a particular instant, not over a period of time, over an interval. So there's two possibilities. One is that it's a straight line graph. And in this case, it's easy because the instantaneous velocity is equal to the average velocity. And how come? Well, because the velocity is constant. The speed there is the same as there, is the same as there, is the same as there, and there, and there, and then there. And over that small interval there, and the small interval there, and the small interval there, right? They're all the same. So you can pick literally any 2 points you want, find the slope, and that's going to be the instantaneous velocity. Okay, so all you need to do is pick 2 points on the graph, any two, find the slope, that's your instantaneous velocity. Pretty easy, right? Provided that you can do slope. I'm hoping you can. The problem lies is when you get to curved line graphs, and we saw this in the notes. You remember there was the picture of the guy with the, looks like a professor, right? When it's a curved line graph, okay, we need the slope of a curve, which isn't really that possible to do without some calculus, although I did show you sort of how to do it, right? So the idea is that if I'm trying to deal with the slope right there, then the slope of C is a pretty good approximation. It's like the average for that interval. But if I pick those 2 points, then that might be better because they're close together. And in fact, if I pick those 2 points right there on slope A, well, that's even better because they're so close. And if I continue that process down and I get closer and closer and closer, 2 points closer and closer together, then in effect what happens is that the curve does what? It straightens out. Because you're so close, it's almost a straight line. And that's that whole calculus idea, and some professor in your future is going to explain that to you. Okay? And then what they do is you take that little teeny tiny line and you just drag it out, right? Make it longer like that, and then pick 2 points and do your tangent line. So that's all you really need to do. Okay? And that's sort of what they're talking about here, right? So a tangent line is simply a line that just touches the curve. So the tangent line here is this straight line, right? That line there. That's your tangent line for this particular point. Now, if the curve happened to do this, again, is it okay if the tangent line crosses it way up there?
Yes.
Yeah, because it's now sort of like a new equation. It's a new part of the curve, right? So we're just talking about this part right here. So then you just pick any 2 points you want, find the slope, and that's your instantaneous velocity. That's all there really is to it. Okay? So here's a couple practice ones. Now, this is a little bit of a challenge. I really do need to sort of fix that curve, because it's probably not the best curve. So what I want you to do is I want you to find tangent lines for A, where is it? A, B, and C. So draw tangent lines for A, B, and C. Find the slope. Are you going to get exactly the same value as your neighbor?
No.
Probably not. Okay, within certain intervals, probably okay. So I'll give you a few minutes to try that while I mark my attendance, and then we'll check those. I'm going to give you some answers, but you need to remember that, where am I? Yep. Mine may be a little bit off for yours, right? Like, you don't have to have exactly what your neighbor has, right?
So the test I won't get marked up.
No. What I need to see on a test, what I'm looking for, is I'm looking for a line, a reasonably straight line, okay, that is pretty close to what I would think is a tangent line, right? Like, I'm not going to get too sticky on that. If you draw your line like that, well, yeah, right? Okay, I'm looking for 2 points that you are using. Yeah, I don't know, maybe there. Right? Any 2 points, but like, tell me, like, sort of like indicate these are the points I'm using, right? And then okay. No. I mean, you should try and pick lattice points if you can, but sometimes it doesn't work, right? And then I'm looking for a slope calculation. And if I see all that and your number is, kind of sort of close to mine, full marks, no problem. Okay? So I've got for A, I've got 1.2 meters per second. I knew someone was going to say that. Okay, I'm going to bore you with a little bit of statistics then.
What was yours?
Right away I said 1.2 before I even was finished. Miguel yelled out, 1.25. 1.25 minus 1.2 is a difference of 0.05. Divide that by 1.2 and express it as a percent, Marie Miguel. Take 0.05, divide by 1.2, and express it as a percent. Wait, let me guess.
Yes.
No, let me guess. I'm going to say it's less than 4%.
It's 0.41.
0.41%. Not 0.41, not 41%, but 0.41%?
41%.
It's not 41%.
It's 4.1%.
4.1%?
Yeah.
So you were wrong.
So you're wrong.
Pretty close, though.
You were wrong though.
Do you think being within 4.1% is close enough?
No.
No, absolutely
That
it's
could be
close
a
enough.
fail.
Close enough, you guys.
Well,
I would say my answer is 1.2, and you've got anywhere between 0.6 and about 2. I'm going to give it to you without even I can look at it. Yeah, no problem. You got 47, you got a problem.
I got one.
No one's going to have 2.5. It's not. Okay.
Well, the scientists were 4.1% off of the calculation fields bomb are going to die.
They would have a range of acceptable values. Nothing is ever exact. They would have a range of what's acceptable. Okay, I'm going to give you the next number. I do not want to hear another, a nanosecond later, your version and ask me for confirmation that everything is okay. B, I have 2 meters per second.
Oh, yeah?
I got 1.2. I got 1.25.
You just can't resist, can you?
No, it's too fun to run the box.
Is that why they do it, you think? I think you're just looking for confirmation. Oh, I thought you...
I know you're wrong.
That's a great question, Connor. You're absolutely right. Good for you. You're right. C, I would have minus 1.5.
Minus 1.5. Last one.
If it's not negative, you got a problem, right?
Negative 1.
All right. You got the rest of the period. You got 4 graphs to cover. Okay? The answers are on the back. I've checked them 1,000 times. They are correct. Go.